Okay, guys, I've decided to make some additional videos for you to help you in preparation for the test, which is coming up. So I'm going to go over some review problems with you guys. So feel free to look this over and for help. So to solve by factoring, and again, we're on page 41. To solve by factoring, we always want to make sure that it is set equal to 0 first. That's very important on all the problems that I do. So after you look for, or after you set it equal to 0, do I have a GCF first? We're always on the lookout for that. So, and then after that, I go forward with other methods of factoring. So, number one, do I have a GCF? Yes, I do. 8 and x. Actually, let me give myself a little bit of room down here. So 8x, remember it's the smallest exponent. The x is common to both of them. So then you have one parentheses, and you need to divide by your GCF to see what's left over in the parentheses. So that would be dividing 1x plus 2. The x's cancel here. 8's cancel here. All right, now we do not stop here. We have an equation. We have to find out what x is equal to. So we need to set, now that it's factored, you know it's factored when there's no more exponents. So we can set each of these factors equal to 0 and solve. By the way, there are a little bit of shortcuts here. Some people can go right from here to answers, but I'm going to show you the better explained way. So we set up these factors equal to 0. It's just two little baby equations, and then we would solve them. So the first one, I would 8 times 0 is 0. And the second one, we would subtract 2 to get negative 2. So there's my two answers. Number 2, remember the first thing I said is we must set it equal to 0. So I need to subtract 45 to bring it to the left side of the equal sign. So now it is set equal to 0. I check to see if I have a GCF. No, I do not. There's nothing common to all of them. So what way of factoring would this be? This guy is the easy trinomial. When there's nothing in front of the x squared, there's nothing here. So we go to 2 parentheses. Now my sign rules, remember I always look to my C term first. When the C is a minus, that means my signs are plus, minus. And when your signs are different, the rule for the numbers is you need to choose two numbers that multiply to get 20, multiply to get 45, and subtract to get negative 4. So in other words, they multiply to get C, subtract, or add to get B. So what I do is I take the 45 and I pull it to the side, and I start listing numbers that multiply to get 45. I always start with the number 1. 1 times 45, well, that doesn't subtract to get 4, so that's garbage. 2, 3. 3 goes into 45. When I divide, it's 15. They do not subtract to get negative 4. That's garbage. For 5, 5 times 9 would be 45. And you can see that's my combination here. They subtract to get negative 4, or subtract to get 4. Now, the signs, be careful. One has to be a plus and one has to be a minus. Which is which? Well, the tip that I showed you many, many days ago is the sign of B goes to the bigger number. The sign of B in blue that I just circled is negative. So sign of B goes to the bigger number, which is 9. So the 9 must get the minus. Therefore, the 5 goes with the plus. So now we need to get our answers from this. So we do our little baby equations. And they're very easy to solve. So the first one would be negative 5. Second one, add 9 and get 9. Next up, it is set equal to 0. Do I have a GCF? Remember, my first thing, always, do I have a GCF? Yes or no? Yes, I do here. 6 goes into 150. 150 divided by 6 is 25. So I have a GCF of 6. And then I need to divide by 6 to see what's left over in the parentheses. So that would be x squared minus 25. Can I factor more? Yes. I can see that exponent. It shows x to the second minus 25. That is a difference of squares. If you do not remember difference of squares, you may want to look at one of my previous Edpuzzles or go into YouTube and type in difference of squares and refresh on this. It's a very easy way of factoring, but people often forget about it. So difference of squares is 2 parentheses. I put x squared by accident. Should be x's in each. The signs for difference of squares are always plus minus. And then the rule is that number 25 is what we call a perfect square. So we square root it, and we get 5s in both parentheses. Now, time to get answers because we're fully factored. The 6 does not have an x with it. Therefore, the 6 can be crossed off. It does not contribute to getting an answer because it does not have an x. So I set up my little baby equations here, set my factors equal to 0, and I solve. This guy would have to be -5, and this guy would have to be 5. Easy, easy stuff. If you guys put in the work and the practice, you guys are going to do good on the test. You got to put in the work. Number 4 is not set equal to 0. It looks intimidating, but go with your rules that I tell you. First rule is set it equal to 0. So we need to subtract x to move it to the left side of the equal sign. Then remember, the second rule is always, do I have a GCF? I actually do here. I have a GCF, and it's x. X is common to both of those terms. So I need to now divide by x to have 3x minus x divided by x. Remember, anything divided by itself exactly is just the number 1. And now you can see I don't have any more exponents. Therefore, I know I am done factoring and I'm ready to go get my answers. So don't forget this guy in front. That's important. That's an x. So x equals 0, and there's an answer right away. And then 3x minus 1. This is a little two-stepper. First thing we would do is add 1. And then we would divide by 3. And we have x is 1/3. Number 5. Oh, I really hate this one. I hate hard trinomials. I don't mind doing them myself, but explaining them can be a little bit of a pain. I know that I taught you guys using the guess and check method, so that's what we're going to do here. By the way, I did go through my mental checks. Yes, this is set equal to 0, and no, there is no GCF here. There's nothing common to all 3 of those terms. So I refer to this guy as a hard trinomial. So I'm going to use the guess and check method. I'm going to put up 2 sets of parentheses. By the way, if you need to look up more on this online, what you want to do is type in factoring trinomials when x is not 1. I'll repeat that. Factoring trinomials when x is not 1. Okay, so what we do is we take a look here, that 2x. Well, 2x can only be broken down as 2x and 1x, so that's simple. No worries there. Now, the 3, then we look to the C term. 3 can either be 1 and 3 or 3 then 1, based on the order I put them in parentheses. Let's do the 1 and 3, and we're gonna guess 1 and 3, and now we're gonna check it. By the way, my signs here obviously have to be plus plus because there's no minuses anywhere. Now remember, for the check, you want to multiply the outside numbers, multiply the inside numbers, and then add them together. They add up to 7x. That's no good. I need them to add up to 5x. So my guess was not good. 1 and 3 does not work out. So now I'm going to reverse the order. I'm going to try 3, then 1. So I multiply the outsides. 2x times 1, 3 times x. I add them, and I get 5x. There it is. I got my b. So I'm good. I now have it factored. My factors are 2x plus 3 and x plus 1. So now I can go ahead and start getting some answers here. Set up my equations. Factors equal to 0. The first one is going to be a two-stepper. We need to subtract 3 first. And then we divide by 2, and we'll call that negative 1.5. And the second one, just subtract 1, get negative 1. Letter C, go over your checks for factoring. Is this set equal to 0? No, it's not. I need to add 12 to move it to the left. Make sure it comes over. Oh, I put that out of order by accident. Should be minus 15x, then plus 12. Has to be in that standard form. All right, now remember your next check. Do I have a GCF? Yes, I do. 3 is my GCF. 3 goes into, of course, itself 3. It goes into 15 5 times, and it goes into 12 4 times. And then we divide each of those terms, 1 parentheses. Just remember, guys, when you are doing GCF, it's 1 parentheses. Now that 3 that I took out does not have an x, so that's not going to, we might as well just cross that off. Since it doesn't have an x, it's not going to help us get an answer. So take a look what's left over. I have an easy trinomial. So set up 2 binomials. My signs. Remember your sign rules. You may want to look that up. Trinomial sign rules would be, remember, we look at the C term first. When that's a plus, then we look that when the C term's a plus, that means they're both the same. Then we look at B and go, they're both minus minus. So now I need factors of 4 that add up to 5. It can either be 1 and 4 or 2 and 2. Obviously, they need to add to 5, so it should be 1 and 4. All right, remember the rule. Your two numbers multiply to get C, add up to get B. Have that phrase in your head when you're factoring trinomials. Okay, guys, so we have it factored, so now I'm setting up my baby equations equal to 0, and I'm going to get my answers. The first one would have to be 1, the second one would have to be 4. Number 7 is set equal to 0. That's good. Now I'm checking for GCF. Yes. 2, 14, and 24. That would be a 2. Not an x with it. The 24 doesn't have an x. A lot of people want to put x all the time in GCF. Please don't do that. The 24 does not have an x. If there's a term that's missing an x, the x cannot be in your GCF. Remember, we call it a common factor. If it's not common to everything, it's not going in the greatest common factor. So now we're going to divide by 2 to have 1x squared plus 7x plus 12. Okay, so that 2 that's outside does not have an x, so we can just drop it. It does not help us get an answer. We have an easy trinomial here, so we can go ahead and do 2 binomials. Signs are easy here. Everything's plus plus. And this is a really easy problem from this point forward. Two numbers that multiply to get 12 and add up to 7. That's second grader can do that. It's 3 and 4. So now we're going to, it's fully factored, no more exponents. So now I'm setting up my baby equations. And I'm going to solve them. First one, subtract 3. Second one, subtract 4. And that guy's done. Number 8, I go through my checks again. I need it equal to 0 if I'm factoring. So I need to subtract 10x from both sides. And from there, I'm checking for GCF. Yep, 5 and 10 would be a 5. And x is common to both, as you can see here and here. So go with your smallest exponent, so that would be the x. And now I'm going to divide by 5x. So that would be 1x minus 2. No more exponents, so I know I'm ready. I'm all factored, so now I'm ready to get my answers. I'm going to get 2 answers here. 5x equals 0. X minus 2 equals 0. So this first guy would be 5 times 0 is 0. Easy there. And the second, add 2 to get 2. Okay, this guy is set equal to 0. Do I have a GCF here? No, I do not. Now, I would say, all right, this looks like an easy trinomial, so I would go, all right, x plus. I was actually working this out a little bit ago. And I would go, okay, 2 numbers that multiply to get 13 add up to get 12. Well, there are only 2 numbers that multiply to get 13 are 1 and 13. They don't add up to 12. So actually, this is a bad problem. You cannot factor it, okay? If you were to solve something like this and it's not factorable, you would technically use the quadratic formula. Don't worry about that. That will not show up on the test. Everything, if I say to factor on the test, everything will be factorable. By the way, when it comes test time, you must follow directions. If it says to factor, you factor. If it says to use quadratic formula, you use quadratic formula. If it says solve by square roots like this, you got to solve by square roots. You got to know all of the methods. Okay, number 10, solve by square roots. Remember, we can solve by square roots when an x squared term is showing, when a constant is showing, but when you don't have like a bx term, you don't have a regular x. So we learned how to solve this, and the first rule was to get x squared by itself. So we need to add 45. Once x squared is by itself, you get rid of the exponent by square rooting. They are opposites. So it'll be x equals. Remember, this is going to technically have 2 answers. You must put a plus minus to represent your 2 answers when you're square rooting to solve an equation. Now 45, I want you to think of the perfect squares. And we'll go higher if we need to. So is there a perfect square that multiplies evenly into 45? I would say yes. that 9 right there, such as it can become square root of 9 times the square root of 5. And then the square root of 9 is 3. And bring down your square root of 5. So you do have two answers here, 3 root 5 and negative 3 root 5. Moving on to 11. I'm going to use my rules that I said in number 10. The first rule was get x squared by itself. So I need to subtract 3 from both sides. Then I need to divide both sides by 14. And now that x squared is by itself, I want to take the square root of both sides to cancel the exponent. So x equals, you need to throw in your plus minus, and the square root of 2 cannot be simplified. So your answers are square root of 2 and negative square root of 2. Okay guys, that's it for part 1 of this video. I will continue with more video short. Check for part 2.